This is Xinye. This is my Lab 2 assignment 2 for cse564. Lab 2 implements fundamental data clustering and dimensionality reduction. The dataset is used in this experiment is from a Chicago public house sales dataset. Here's the code part. This dataset is an information-rich dataset which includes 1,460 sample points with 51 dimensions. I used Flask Python library to pre-process the dataset, which provides for the conversion of numerical variable to categorical variables, replacing known values, and simply through two methods. And also, in order to ensure the efficiency of HTML operation, all calculation parts are completed through Flask library, including training k-means cluster, calculation of covariance matrix, calculation of eigenvalues and eigenvectors, PCA dimension reduction, and MDS dimension reduction. Here is the HTML. The final effect displayed on the web page is a total of 6 plots from top to bottom. Here. And each figure, which contains 3 datasets, the original dataset, random sample dataset, and stratified sample dataset, is set with 3 buttons nearby, like here and here. Click on button can change the dataset figure in terms of the datasets. And when clicking on button, color of the button will change, so that highlight we are using the button. So let's see the first plot. The first one shows how to select the L ball at the cluster number using the k-means algorithm. Like here, the optimized cluster number is 14. The second figure shows the intrinsic dimensionality of the dataset selected based on the script plot. So we can say the intrinsic dimensionality of original datasets is 88. The intrinsic dimensionality of the random sample datasets is 58, and the 58, which means 58 principal components, can explain the 75% of the cumulative covariance. And we can say the intrinsic dimensionality of stratified sample dataset is 57. The third figure shows how to get the top 3 attributes with highest PCA loadings. We can see the first 3 attributes is the type of the building, which means the type of the building. This is we can see the original dataset first. This is for the type of the building. This is overall qualification of the quality of the house. This is a sale condition. And we can see this for random sample dataset. Also, the top 3 is type of the building. This means the rental house, which year is the rental house rebuilt, reconstructed, and this means the finished area of the basement, the type of the finished area of the basement. Let's see the stratified sample data set. Also, the top three attributes are type of the building, overall condition of the housing, and the type of the finished area of the basement. The fourth figure shows 2D scatter plot mapped by top two PCA vectors. So this original data set, this is used original data set, looks like this. This is used the random sample. This is used stratified sample strategy. And the next one, the fifth image, shows the 2D scatter plot mapped from MDS. This is for original dataset. This is for random sample dataset. This is for stratified sample dataset. And the last one is scatter plot matrix. This one shows the scatter plot matrix generated by top three highest PCA loaded attributes. So this is for original dataset. This is for random sample dataset. This is for stratified sample dataset. So basically, except for the first plot, all the charts can draw plots by clicking three buttons next to the image according to their datasets. So let's say the difference between three datasets. The data of random sample and the stratified sample based on the cluster similarity the intrinsic dimensionality is different, which means let's say which part here, which indicates that after reducing a certain amount of data, the data set is more characteristic and will indeed reduce the noise of the dataset, but it will also introduce some bias. However, because the sample data is near the source and the origin dataset, the script plots of all three appear airball at the 10th component. I think this is similar. And I think the difference, I think the reason why the airball of the number of principal components and the number of principal components which can explain cse564 75% cumulative variance is different is that encoding of the categorical variables data set adds many attributes that are not important. The existence of data points containing such unimportant attributes is reduced by sampling, making the datasets more meaningful and streamlined. And the specific difference from 3 data sets, we can see this plot and see these variables, and the specific explanation is written in the report. So basically that's it.